Thanks for being here today. I'd like to thank Apiculture New Zealand for inviting me to present. It's been a bit of a long battle to get here. I only got in last night due to some flight delays. I'll be giving you an update on our research that's occurring across the ditch in Australia and just how this is growing the leptosperm story. So our research project is a united effort between industry and government and the universities. We're aiming to undertake and understand and set a starting point for Australian leptospermum. Dr. Peter Brooks and myself are based at the University of the Sunshine Coast, where we're doing testing on nectar, honey, and also undertaking field work to investigate potentially new sources of leptospermum honey. And our collaborators in Sydney are undertaking work on looking at the medical properties of the Australian leptospermum honeys, because there's quite a wide variety. So earlier this year, you mostly would have heard about this in the media. Results were published that demonstrates that Australian leptospermum honey exhibits the same non-peroxide activity as New Zealand Manuka. We've got the same correlation with increasing MGO. We also get increasing NPA. We've squared our NPA because it turns it from the curve you're familiar with into more of a straight line. And just like the New Zealand Manuka, the results kind of fall off at the lower end of the scale due to the dilution of the honey, so it doesn't show up on the NPA agar plate test. So as part of the project, we've been receiving honey samples from beekeepers around Australia. And this has helped us identify new leptospermum possible field sites to look into, as well as providing information that we will be using to link the activity of the leptospermum species in an area to the honey produced in that area and seeing how those link in together. And in return for doing this, we've been providing the Australian beekeepers with their activity levels of their honey, their DHA, HMF, MGO, and this is helping grow the Australian beekeeping industry knowledge of what a leptospermum honey is and how they can possibly get it, because this is still quite a learning experience over there. So the majority of our samples are from New South Wales and Queensland, as these are some of the more known hotspots for the leptospermum honey. And we also have a little bit from Tasmania, because it's also quite well known for it, and well, they've got Scorpion, which is the same as Manuka. We've had pretty good support so far, although it has 881 samples processed. I'm pretty sure we'll be about 900 by the time I return to the laboratory. We're providing a lot of good feedback to beekeepers. So out of those donated samples, it's actually been quite impressive seeing a large majority of them fall within the range of 200 to 600 MGO. And we've got the occasional sample over 2,000 MGO, which from memory that would put it up around what would be an NPA 30 plus. And the majority of the honeys are falling between a 10 and 15, with definitely a few up towards the 20. We also have quite a lot of low samples, but as this project's definitely a discovery project, we've been testing some non-leptospermum samples, and we've also been getting some samples from beekeepers in maybe what wouldn't be seen as traditional leptospermum areas, because we're just not quite sure what's out there, because in some areas of Australia, the records are quite limited on where leptospermum do grow. So I know your eyes will mostly be drawn towards the brown yellow part of that map, which is the border of New South Wales and Queensland, where on average most of the honeys can get up to between 20 NPA, between 15 and 25 in some of the good areas. There's a reason for that, and that's due to the species there, which I'll cover later. But what I think is important about this map is that every state, bar the Northern Territories, which I believe we just haven't got many samples from there, but every state in Australia is capable of producing what would be regarded as a medically active leptospermum honey. Obviously it's always dependent on conditions in the environment, but the possibility is definitely there. So there are around 87 species of Leptospermum in Australia, and we've currently tested around 45 of the species with just over 2,500 samples. Now, this has been a large undertaking, and it couldn't have been done without a lot of collaboration with a lot of different people throughout Australia. We've definitely been reaching out to different beekeepers and other interested parties, and they've been helping us take samples. I myself have travelled to every state we've got samples from, and just released a book in Australia for one area with photographing the species and just building up which species are where and how active they are. We're finding quite a range of results. With some of the species have no activity and some have over 20,000 DHA, which correlates to, which in theory could give a honey that's 2,700 MGO if allowed to mature and is monofloral. So a lot of possibility there. Leptospermum species is definitely quite diverse around Australia, and as over millennium they've had quite a chance to adapt. Adapt to local environments you've got some plants like Leptospermum spinescens, which you can see is the big open flower cup there. That's actually the cup of the flower. It was nearly 2 centimetres big. It's quite an impressive looking plant. A little odd looking, but quite impressive. All the way to, and that occurs in the sand plains of Western Australia. And in contrast, you've got Leptospermum speciosum, which is one of our higher producing species, and that occurs in the swamps around New South Wales and Queensland. And just like the Manuka in New Zealand, they thrive in areas that have been recently cleared, or definitely in Australia, burnt. And also in poor soil conditions, they tend to become dominant. So swampy areas, very sandy areas where other species can't get established well, these guys just thrive. So just looking at some Leptospermum from the eastern states, as you can see, some of the species there, Brivips, Coraceum, Levigardum, Lame autumn. There's no we didn't find any DH in the nectar, so these aren't capable of producing necessarily traditionally medically active honey from an MGO sense, but there may be other possibilities. These ones are also a little bit disappointing because they are dominant in some areas of Australia, so a bit of a bugger. But what is interesting, though, in relation to Manuka, is the continentale and juniperium are actually close cousins of Leptospermum scorpion, and they share very similar average activity, very similar appearance. They're a bit of a pain to separate, and they're also just as prickly as Manuka, which makes them a right pain to do nectar sampling of when you've got to grab the branch. Also, Liversidgii there is also quite an interesting plant. It's one of the few lemon-scented, it's considered a lemon-scented tea tree. It's got pretty good activity, and it flowers quite later compared to other species. It flowers more December, March, where most of the other species are flowering between August and December, although I'm pretty sure right now there's some in flower in some parts of Australia, especially up northern Queensland. So Polygon folium, that's more commonly known as jellybush, and as you can see, it's quite an active plant compared to what would be the average for Scorpion, which is around 2,000 maybe, and that was comparable to New Zealand from my masters. I think that New Zealand is more up around 4,000. And Polygon folium can grow from northern Queensland all the way down to southern Sydney, so it grows for quite a large area and it's quite a robust plant. Unfortunately, it tends to also grow with, in some areas, the Semibacardum and Trinervium up there, which have no DHA, which isn't so great. They co-flower. However, they also co-flower with the Speciosum and Whitey, which are the two highest species we have on record in Australia. And as you can see, they're about 3 or 4 times on what an average Scorpion could produce. So coming back to this map, those dark areas are also very similar locations where the Polygon folium, the Speciosum, Whitey, Liversidgii, and also Juniperium all grow together, and they all have overlapping flowering periods, and that's definitely helped make that area quite a hot spot for activity. Now, just like New Zealand, there's definitely a bit of a range in nectar activity for the species. So this is a graph for Polygon folium. It shows kind of the number of samples we have over the DHA range, and most of them are around between 6,000 and 12,000 DHA, but there's also quite a few that are over 20,000 up to 30,000, so there's good stock there for possible plantations. Now, if we go and look at the home of Manuka, where it came from initially before it blew across the ditch, Tasmania, there's not necessarily any high activity plants there, but there's quite a good bit of activity in Tasmania, and the two ones that don't show any DHA, Glucosynths and Navigatum, well, they flower outside the major season. A problem with Tasmania is leatherwood flowers about the middle of the leptospermum flowering season, and the bees love it. And it's not just the eastern states that have leptospermum, as WA also have some native species. Leptospermum nitens has quite a good bit of activity, and it also has species that aren't active as well. Now, another relation to New Zealand, Kunzia ambigua, cousin of Manuka or Kunzia ericoides. Just like the Kunzia in New Zealand, it contains no DHA in its nectar, and it looks quite similar as well. We've also been doing some study with all our samples. We've been able to look at the effects of elevation on some of the species. For the Polygon folium, we've definitely found that the coastal plants give the highest activity, and as you head inland and get to higher elevations, the activity does drop off, but in saying that, it's still quite comparable to what would be average Scorpion. We've also been doing some work. Leptosperon's been suggested as an identifier for Manuka in New Zealand. Well, it's also a really good identifier for testing monofloral qualities for the Scorpion in Tasmania. We've seen the same trends. The more the leptosperon correlates with the DHA and the MGO. So the more leptosperon, the more monofloral the Tasmanian Scorpion will be. Just like to say thank you to some of our project's supporters. We're funded by government and the major universities. And if anyone wants to try and get in contact with me later on, I'll be here for the next 2 days. You can keep an eye on our research project at the Oz Honey Project, and our Honey Lab runs a Facebook page at USC Honey Lab, which we put talks and information up on as well. Thank you, and I believe we've got a little bit of time for questions, if that works.
Actually, we can have a couple of questions, yeah. Remembering though that Simon is here right through to the conference.
Simon, thank you for that. Several years ago, when we had somebody starting to talk about the Australian leptospermum possibilities, I suggested that if I was 20 years younger, I'd probably be trying to pack my bags and move over to Australia and invest my money in that. Is your industry embracing the work that you've done here, and do you see that as being a major feature in the future for Australian honey?
The industry is embracing. One of the issues that has been is because of the similarities between a lot of the species, they all kind of look quite similar. People are getting this, and some species are active and some species aren't active. So they'd go to sites and go, oh, this honey isn't active or it's quite weak. And what they've done is they've left the hives there for too long. While they've seen the white leptospermum like flower, and they've been catching the inactive species and the active species and blending that all into one honey. With our research, we're now able to inform the beekeepers, and they are taking this on board, which species are active, which ones aren't. So they're now adjusting how they manage their hives to ensure they get a much higher quality, more monofloral active leptospermum out of that.